Alrighty, hey guys, my name is Tim and I'm going to be showing you what I came up with. This is going to be for aerobic respiration, and I'm going to be showing you a simplified graph and then a simplified table of what goes in and what comes out. So we're going to be starting out with glycolysis, and this is going to take place in the cytosol of the cell. This does not happen with oxygen, even though it is part of aerobic respiration. So essentially what goes in is a glucose, 2 NADH come out, 2 ATP come out, and 2 pyruvic acid. Want to get more into depth? What goes in is 1 glucose, 2 ADP, and 2 NAD+. Comes out is 2 pyruvate, 2 ATP, and 2 NADH. Okay, so moving on to the transitional phase, this occurs in the mitochondrial matrix. What goes in is a pyruvate and an NAD. What comes out is an acetyl-CoA, CO2, and NADH. The coenzyme A right here doesn't connect with the CO2, it connects to the acetyl-CoA at the end. And also just to clarify, the glycolysis and the transitional phase, those two have not been aerobic. This happens aerobically. This is the citric acid cycle. And the main goal of the citric acid cycle is to generate energy-rich electron carriers and stuff like that. So as shown, pyruvic acid goes in, acetyl-CoA goes in, and it goes through an endless cycle. It's pretty complicated, we've seen it before, but I just wanted to do this one right here, the table, and it just shows what goes in and what comes out. So acetyl-CoA goes in, 3 NAD plus goes in, 1 FAD goes in, and 1 ADP goes in. Comes out is 2 CO2, 3 NADH, 1 FADH2, and 1 ATP. This happens aerobically, and it happens in the mitochondrial matrix as well. Alrighty, so this is the last step of aerobic respiration, and this is the electron transport chain. So this is the citric cycle right here. It releases energy into the electron transport chain right here. And what happens is hydrogens move across the radiant or the gradient right here, and then they move towards the chemiomosis. And what chemiomosis does is it synthesizes ATP, and it uses the hydrogen ions to power that. And the goal of the whole electron transport chain is to produce as much ATP as it possibly can. And usually it's around like 20 ATP per trip around the cycle. So essentially what goes in is NADH, FADH squared, ADP, and O2. What comes out is NAD plus, FAD, ATP, and H2O. So yeah, this sums up aerobic respiration, and a fun fact about this is that if you were to do things anaerobically, so anaerobic respiration, you'd only get 2 ATP compared to 28 ATP. So this just shows that aerobic respiration is a lot more effective in creating ATP compared to the other option, which is anaerobic.